Okay. So what I was saying was things like your car decrease in value as time. That's a decay model. Okay. And so we use things like that. But then money in the bank increases. So that's a growth model. So we're going to talk about both of those. And that's kind of why we do the project also. All right. So growth and decay. When we talk about growth, I named several examples when we started talking about it of things that might grow in value. Do you remember what any of them were? Okay.
Money in the bank.
Money in the bank. We'll talk about money second. First, when we talk about growth, I think I mentioned, maybe it was fourth block I mentioned it in. Things like collectible, people collect stamps, or people collect like comic books, baseball cards, stuff like that. One thing that does increase exponentially, and a good example, is population, right? Yes.
Yeah, because I didn't need to know.
Zombies. Zombies grow exponentially, right? Huh?
Well, it depends on the market.
It depends, yeah. That kind of fluctuates up and down. Let's say Chandler bit somebody today. He's a zombie. He bites somebody today. Chandler bites Wills because he's right beside him. So day 2, we have 2 zombies, right?
Yeah, no.
But then on day 3, each of them bites somebody. So how many zombies do we have on day 3? We now have 4 zombies on day 3. Then on day 4, each of those bite one. So how many zombies do we have now?
16.
Right? So it's increasing exponentially. It's doubling every day. Do you see the difference? It's not a linear growth. It's an exponential growth.
It's like cells.
It is exactly like cells when they start splitting. That is, yeah, absolutely. All right. So, population, zombies. That's my favorite. I usually do in my CP class a zombie project. Yeah, like a zombie apocalypse project. All right. Man, now I can't. Oh, cells. What else did we say? Germs, bacteria, zombies. Okay, all those things grow exponentially. Okay, how about decay? What are some things that decay? Oh, and we should say money too, because it does. We'll come back to that. Car value over time. That's exactly right. Right. Well, it kind of like decays, and then it could possibly start increasing depending on the car. What else might decay in value? How about something you all have right now?
My pencil.
Cell phone.
Right? That bag phone that my mom and dad had when cell phones first came out is worth nothing now, right?
Like really any technology.
Any technology really decreases in value. So those are decay models, right? They're never going to dip down below 0 because you won't. I mean, hey, I guess you could pay somebody to haul something off for you, but still, yeah, okay? So those are examples of decay. So let me show you how we calculate this. Let's start with growth. Our growth model for anything other than money is A times 1 plus R to the T. Nobody's going to say, Miss B, what do those variables mean? I'm happy to tell you what those variables mean. That's a 1 plus R. That's 1. There you go.
Is R great in 2 times?
Yes. Good job. R is the rate at which it grows. Okay. But I have to be careful because most of the time you'll say, hey, this grows 7.2% per year. Well, your rate's not 7.2. It has to be written as a decimal. So you got to move that decimal over. So 0.072. Like if you have, this computer doesn't like me to write on it. If I have, for example, if I have 7.2%, then as a decimal, that would be 0.072. Yeah. T is your time. Most of the time, it's gonna be in years, okay? The problem may specify though, maybe you have, y'all were talking about cells that split. Maybe you have cells that split every 30 minutes and you wanna know how many after 4 hours. Well, in that case, if it's every 30 minutes, then in 4 hours, your T would be 8. Because it occurs 8 times over that period of time. Most of the time, however, we're going to be talking about years. Okay. So does anybody have any guesses about what A might be?
Like the start.
That's exactly right. It's your initial amount. What you start with, you have to know where you start. What amount you start with, in other words. Okay?
What is that? 7.29?
It's an example.
That's 7.2%.
That 9 doesn't, it looks like a 9 though.
I'm sorry. I don't know how to make it not. Okay, so.
That was a 9.
Oh my goodness, y'all. Oh, happy Friday. I missed y'all yesterday.
Really? Set chapter 3.
I texted y'all during class.
That dude was so cool.
Okay. All right, so for example, let's say, by the way, this is called, I want to use, your book uses some terminology. 1 plus R is called the growth factor. The whole equation, of course, is a growth model. Of course. So if it increases at 7.2%, then the growth factor is 1.072. Okay. All right, so let's say, for example, you go, let me use one out of the book, it's easier. In 1970, the population of Kern County, California, it doesn't really matter what the county is. The population was 330,000. From 1970 to 2000, the county population grew at an average rate of about 2.4%. So first thing we want to do is write an exponential growth model that models the growth. In any amount of years that we could plug in, so the whole model. T is your variable. T is your independent variable that you can plug in for, so that'll stay. So I want y equals, well, what's your initial amount? 330,000, right? Times 1 plus point, this thing does not like to do a point, I'm going to go ahead and tell you. Point, oh my gosh.
Just tap it one time.
You get it. That's the point.
Hey, good idea. 0.024 to the T. That is my growth model. Yes? Okay. That's the year it started that we started looking at. So what we'll do is, let's say I want to calculate the population in 1995. That would mean my T is going to be 25 because that's 25 years from when we started. Okay, so yeah, plug it in and see what you get. Because you have to move this decimal over twice.
I paid for it.
Y'all are going to have to do this one on your own since I don't have the calculator app. What did you find the population to be?
I got my calculator down. It's 59705
Oh, wait.
Wait. 5970.
53.
Well,
That's if you round it to the nearest person.
So we have, what, about 267,000 more people in 25 years? Let's do the opposite of this. That was growth. Let's do decay. And then we'll come back to some of the growth models for interest, okay? Because those are the coolest. All right, with decay, my formula is almost exactly the same. Yes.
Oh, it's a minus.
Exactly, because it is decreasing in value. All of the variables are exactly the same thing. So let's say, for example, the example in the book is a snowmobile. We'll go with it. It never snows here, but let's go with it. Okay, so you buy a snowmobile. I don't know why you would buy that around here, but okay. You buy it for $4,200. That's pretty cheap for a snowmobile. Decreases 10% each year. Let's do two things here. I forgot to do this with the other one, so we'll do it. One, I want to write the model. Two, I want to graph it.
Why do you want to graph?
Then we'll use the graph to estimate a few things. All right, so the model here, my initial amount is what? 4,200. The decay rate, or the decay factor here?
Just 1.
1 minus 0.1, or 0.9, right? Raised to the t. Yeah. All right, so look at this. This is exactly what we've been graphing, okay? We've done, there's just a t instead of an x, and that's okay. 4,200 times 0.9. Instead of x, it's a t. So when I graph, now these are real life problems. I'm not going to have negative time, and I'm not going to have negative numbers, so I'm good to stay in the first quadrant for these, okay? Where's my asymptote? 0. The k is 0. The h is 0. The k is 0. Yeah, if you do an E one, yeah. But the b is 0.9. And remember, less than 1 means decay. It's what we did the day before E. Give me an easy point on the graph. H, A plus K. Y'all don't forget this. 1, 2, 3, 4. I'm going to call this 4,000. These are my years down here. Come on. All right, it's about right there.
Give me a second.
Yeah. Years.
Wait, what? Yeah, is that?
1. If I plug in 1, well, I shouldn't mix my variables here. T is 1. Then what do you get? Somebody's saying it. 8,000 what?
3,000.
Ah. 3. Right? At 1 year, I'm about right here. So I know it's going to come down and hug this way. Okay? I just need an easy point.